Good morning, integrated science students. I'm posting this video on volcanoes. It's the second installment of, I don't know, there'll be a couple more. Posted it on, man, I gotta flip my calendar over. This will be the 4th of May. So it'll be the week from the 4th on. You'll want to watch this early because starting tomorrow, the questions, actually probably starting today, the questions on the daily quizzes are going to be based off of these video lectures. So make sure you watch them. I can tell when you don't. I'm going to try something new. I haven't done this before. I'm going to share my iPad screen because it's easier for me to draw my beautiful drawings. We know how beautiful they are when I write them on my iPad. When I use the whiteboard that's embedded in or that I can use for Zoom, it's stupid. It's not as beautiful. We all know how particular I am about my beautiful drawings. So let's go ahead, get to whiteboard. All right, we're just gonna jump right into this. This is the basic anatomy of a volcano. Remember that there's 3 types of volcanoes. There's the shield volcano, there's cinder cones, and there's different subcategories of cinder cones. And then there's the composite volcano, sometimes called the stratovolcano. This one is going to be based off of the stratovolcano. Strato means layer. First thing I want to do is just give you a reference. Here is the surface of the Earth. And I'm leaving a gap there because underneath the surface of this Earth, I'm going to have a huge reservoir of molten rock. When it's underneath the ground, we call that a magma chamber. Now, when I can fit the names of things in here, I will write them on there, but if there's not enough room because it's kind of small, I'll just point to what I'm talking about and tell you the name and you'll have to write it on your own. But when I can fit it in, I will. So what we have under the ground, we have this magma chamber. It's molten rock somewhere in the neighborhood of 1200 to 2000 degrees Fahrenheit. The source of heat is called geothermal. It's the result of the decay of radioactive materials, and we learned about that when we did nuclear physics, one of your favorite things that we covered, right? Anyway, so it melts the rock. Remember the type of rock that is melted, the magma, the makeup of the magma, what minerals are in there, silica, as well as the things that are trapped in the magma are going to contribute to the type of eruption that we have. So what happens, and I'm going to make the magma chamber, I'm going to make it this kind of peachy color because it kind of says that it's hot. But once it reaches the surface, it cools down and it turns into rock. But anyway, when this magma finds a weak spot in the Earth's crust, it could be just a natural crack in the rocks or a thinner portion of the rocks, whatever. This is under pressure down here. We've got a lot of pressure because it's hot and it's expanding and it puts pressure on the rocks, surrounding rocks around it. When it finds a weak spot, we call that the vent. And from the vent, we get magma reaching the surface, which we now call lava. All right, now, this is just the start of a volcano. When this hardens, it just becomes rock. So now we have this little mound on the ground, and it's the start of a volcano. When this cools, when the magma that reached surface, now called lava, when it cools, it plugs this area. So now we are able to house a much greater amount of pressure from this magma chamber. So the next time it erupts, it's going to erupt with much more force. And it's not going to be this non-explosive flow like we had here. It's going to be an explosive flow, explosive eruption. And it's going to blow the existing rock up into the air. It's going to blow this magma up into the air. It's going to cool and harden. It's going to fall back down. And we will no longer have this layer of lava rock. We'll have a layer of pyroclastic material. I will make the pyroclastic material gray. So now our second layer is going to be not from lava, but from pyroclastic material that has settled. So you can see now that we're starting to get these layers, this strato layers, a layer that came from a non-explosive eruption where lava came out and hardened, and a layer that came from an explosive eruption where the pyroclastic material hardened. We're going to talk more about pyroclastic material later. Sometimes immediately following this explosive flow, after the initial pressure is released, we could have another relatively calm flow. So we are going to have another layer of lava, because once that pressure is relieved, then the lava can come out non-explosively. So now we have another layer. Then this is going to harden. This is going to harden. It's going to clog this up. And what do we have when the clog holds that pressure for a really long time? When it does finally erupt, it's going to erupt explosively. And when it does, we're going to get pyroclastic material that shoots into the air, and then it's going to fall back down, and we're going to have another layer of pyroclastic material. Ash, cinders. Again, we'll talk more about the types of pyroclastic material. And then the pattern just repeats itself. We're going to end up with, after we have that initial pressure that's released, then we can have some lava just calmly flow out. You can definitely see the layers starting to develop. So this is where we get that composite, a mesh of two things, a mesh or a combination of non-explosive versus explosive. And the mountain that results has alternating layers of lava flow that hardens into rock, pyroclastic flow, then lava flow, then pyroclastic flow, then lava flow. I'm just going to do this a couple more times, because once the volcano does this a few times, we're going to be able to draw different parts of this volcano. And I hope to high heaven this isn't too hideous for you guys. If you want a better drawing that's not, immaturely done by me, look it up, anatomy of a volcano. You'll see things that look an awful lot like this. So we have our non-explosive lava. And let's do one more layer of pyroclastic. All right. So now we have something that looks a little bit more like a volcano. We've got a cross section here. It's like I cut it, the front of it off. Now let's draw some more parts to this volcano. The area that leads up through these layers we call this area right here that leads from the magma chamber up to the top, we call this the conduit. Sometimes they call it a pipe. It's the initial pathway out of the magma chamber. As it reaches the top, the upper part of the conduit is called the throat. Now, now it gets a little bit more specific. The place where it reaches the surface, we call the vent. Of course, the vent moves as the volcano develops. Originally, the vent was clear down here, this initial weak spot, right? But now in this current day volcano, the vent is the very top, the first place where the lava will, or the magma will reach the surface and become lava. Remember, there's no difference in magma and lava as far as composition. It's just where it's located. Magma is under the ground. Lava is once it reaches the surface. Now, notice this top at the part. It's a little bit wider. It can widen out for a couple different reasons. Normally, when we have that explosive eruption, the one that causes the layers of pyroclastic material, it will blow some of the existing rock away, and it widens this vent. And this is what we call the crater. The wider spot at the top is a crater. Sometimes it's really big and it's called a caldera. That's a kind of a little bit different phenomenon going on, and we're going to talk about calderas in a minute. In your research, you learned that Yellowstone is a series of 3 calderas, and calderas involve the emptying of the magma chamber and collapsing of a mountain. But anyway, the wider spot at the top, right above the vent, is the crater, the place where the magma reaches the surface. When it first reaches the surface, is called the vent. The upper part of the conduit or the pipe is the throat, and the conduit leads from the magma chamber up to the throat. Now, some other parts. If we have another eruption, then you'll see, let's forget the other eruption, let's just forget that. Sometimes we name in huge parts of the volcano. If we have this whole side right here, this is called the flank. It's just the side of the mountain, all right? Now, sometimes underneath, the magma doesn't always just come up straight up through the conduit, through the throat, out the vent. It doesn't always do that. Sometimes it might find a weaker spot along one of these sides, all right? Let's say that as this lava is coming up, looking at this grade, we just had an explosive eruption, and now we have lava still making its way up here, and I'm going to darken this a little bit. I'm going to make that lava so that you can see that it's lava going through here. So let me darken this in. Sometimes that lava is going to find a weak spot before it reaches the vent. When it does that, it will cut across these layers. I can get this to work. Across these layers, you see how it goes? It cuts across the existing layers, almost perpendicular like. We call that, whenever we have, and then once it hardens, we would call this a dike. D-I-K-E. And it's just the result of there was a weaker spot along here that the magma managed to intrude into those existing layers. Now, sometimes it might hit something, maybe it reaches this layer, which was originally lava, but now it's hardened into rock, and that is really, really tough. That just happened to have a bunch of silica in it or whatever, and it can no longer cut across the layers. What we end up with then is it's going to go in between these layers. It's going to fill in between these layers, and we call that a sill. Now, let's do another little, they call it a dike. Sometimes they call it a branch pipe. When it finds a weak spot and it goes across the layers, it's called a branch pipe or a dike. But let's have one over here. Let's say there was a weak spot, cuts across, and it doesn't stop and form a sill. It doesn't. It continues to find weak spots all along here. It's going to keep traveling, and it reaches the surface, and we get another little lava flow. And maybe we'll continue to get lava flows. Maybe we might have a little minor, instead of a lava flow, maybe it'll explode explosively, and we end up with some layers of ash. What we've got here on the side of this mountain is a kind of like a little mini mountain, right? Little miniature mountain. We call this, and I don't think I'm going to have enough room to write it over here, so I'm going to write it down here at the bottom. We call this whole structure a parasitic cone. It's just like a little miniature volcano that grew on the side of a volcano, and it resulted from the fact that as the magma was traveling up through the conduit before it reached the throat, once it reaches the throat, it's going to go ahead and make its way all the way up through the vent. But if it does it and it goes across here, we have this across the layers, this dike, and if it reaches the flank and creates another little mini volcano, then we're going to have a thing that we call the parasitic cone. I think that's all the main parts of a volcano that I want you to know. If you can't make any sense out of this the way that I drew it or whatever, seriously, Google any parts of a volcano, and you're going to get a very similar picture to this. But again, this is a composite volcano, composite or strato, because it's layers. It's the result of alternating explosive and non-explosive eruptions. This is going to be your homework for the week. You are going to draw your own picture of a volcano. You can make it a lot more elaborate. You don't have to draw it on an iPad like this. I don't want you to draw it on an iPad. I want you to draw it on a piece of paper. You can include trees on the side of the mountain. I don't care. Of course, I want it colored. You know how I am about coloring. If you don't watch this video, you're not going to know that this is your homework. I'm not going to put the homework into the weekly doc. I'm going to trust that you're watching my videos, and the video tells you, draw me a picture of a volcano. So what I want you to have labeled on it, I'm going to highlight all the parts that need to be labeled. Let's highlight in yellow. I want you to label the flank, the crater, the vent, the throat, the conduit or the pipe. I want you to be able to draw a dike, sometimes called a branch pipe, a sill, when the lava that comes from the dike settles in between layers. I want you to include a parasitic cone. Tell me what the magma chamber is. And then, you know what? Let's throw a little something extra in there. Let's say that your volcano is in the middle of an explosive eruption, and we have this huge cloud right up here. That is going to be called the ash cloud. Ash is one type of pyroclastic material, and it's the stuff that stays in the air the longest because it's the lightest. Ash cloud. When Mount St. Helens blew in southwestern Washington, I'm trying to say that right, I was in southeastern Washington, and I got ash from the volcano on my motorcycle seat. It has a long stinking ways, so it can travel a long ways. All right, so homework. Draw me a volcano, color it, make it beautiful. Beautiful enough to make me cry. Include all of the things that I have highlighted, including, let me highlight this last one, the ash cloud. And yeah, there you go. See you guys on the other side.